Hello everyone, my name is Jyoti Kirpa Dharmode. I am a student of Shivaji Rao S. Dondre College of Pharmacy from final year B Farm. In this PPT, I am going to present a topic that is novel synthesis of Coumarin derivatives by using green catalyst, which is our final year university project. Presented by Sonali Dagale, Harshila Dhavane, Atharva Desle, Shraddha Deshmukh and me Jyoti Dharmode. Guided by Professor Manjusha Sanam, which is assistant professor of our college from Pharmaceutical Chemistry Department. Now let's begin with the introduction part. What is coumarin? Coumarin is also known as 2H-chromin 2-on. It is an aromatic organic chemical compound. Its molecule can be described as a benzene molecule with two adjacent hydrogen atoms replaced by a lactone-like chain, forming a second six-member heterocycle that shares two carbon with the benzene ring. It can be placed in the benzopyrene chemical class and considered as a lactone. Coumarin is a fusion of benzene and pyrene ring, hence it comes under the benzopyrene chemical class. Now, history of coumarin. Coumarin was first synthesized in 1868 and it was used in the pharmaceutical industry as a precursor in the synthesis of number of synthetic anticoagulant pharmaceuticals. Coumarins are a type of vitamin K antagonist. The most notable ones are warfarin, acinocoumarol, and phenoprocouman. Nowadays, coumarin scaffold are used as an anti-cancer agent because of their ability to regulate diverse range of cellular pathways. Coumarin is synthesized by using different methods like Pagman condensation, Perkin reaction, Novengial synthesis, etc. Now, material and methods. In recent years, the direction of science and technology have been shifting more towards eco-friendly natural product resources and green catalyst. So, we develop a solvent-free preparation of coumarins using an inexpensive and non-polluting catalyst. All the laboratory chemicals required for this study were procured from SD Fine Chemicals Limited, Mumbai, India. Here we synthesize coumarin's derivative by a Pagman condensation of phenol with beta-keto esters in the presence of silica-supported perchloric acid and silica-supported zirconyl fluoride octahydrate as a catalyst. The structures of all synthesized compounds were characterized from their IR spectra and confirmed from their 1H NMR spectra. Procedure for the general coumarin. A mixture of phenol, ethyl acetoacetate or methyl acetoacetate and green catalyst was added and the reaction mixture was stirred at 130 degrees Celsius in a preheated oil bath. After completion of the reaction, mixture was filtered and the residue was washed with ethyl acetoacetate. The compounds are well known and in agreement with spectral and physical data. Here the reaction represents the fusion of resorcinol with ethyl acetoacetate in presence of H2SO4 gives the 7-hydroxy-4-methyl coumarin, which we got the 85% yield. Procedure for chlorocoumarin. A mixture of phenol, ethyl 2-chloroacetoacetate and green catalyst was added and the reaction mixture was stirred at 130 degrees Celsius in a preheated oil bath. After completion of the reaction, mixture was filtered and the residue was washed with ethyl acetoacetate. The compounds are well known and in agreement with the spectral and physical data. The reaction here represents the mixture of resorcinol and ethyl 2-chloroacetoacetate gives the chlorocoumarin. Now, procedure for green catalyst. First, procedure for the silica-supported perchloric acid. HClO4 was added to the suspension of silica gel in diethyl ether. Then the mixture was concentrated and the residue dried under vacuum at 100 degrees Celsius for 72 hours to afford silica-supported perchloric acid as a free-flowing powder. Second, procedure for the silica-supported zirconyl fluoride octahydrate. The grafted silica gel was stirred with zirconium oxychloride in chloroform, which was heated under reflux condition for 2 hours. The mixture was then filtered, washed thoroughly with chloroform, and the obtained catalyst was dry. Now we synthesize the 4 coumarin derivatives by using these 2 green catalysts. First, general procedure for the synthesis of piperidine derivative. Procedure. An equimolar mixture of 7-hydroxy-4-methyl coumarin and secondary amine, that is piperidine, was dissolved in minimum quantity of acetic acid and then aqueous formaldehyde was added to this. The reaction mixture was refluxed for 7 to 8 hours. After cooling, the reaction mixture was poured to crushed ice and neutralized with aqueous sodium bicarbonate solution. The base precipitated out was filtered on vacuum and washed with water. The crude product obtained was dried and recrystallized with alcohol acetic acid. Now, Second derivative, general procedure for the synthesis of diethylamine derivatives. An equimolar mixture of 7-hydroxy-4-methyl coumarin and secondary amine, that is diethylamine, was dissolved in minimum quantity of acetic acid and then aqueous formaldehyde was added to this. The reaction mixture was refluxed for 7 to 8 hours. After cooling, the reaction mixture was poured to crushed ice and neutralized with aqueous sodium bicarbonate solution. The base precipitated out was filtered on vacuum and washed with water. The crude product obtained was dried and recrystallized with alcohol acetic acid mixture. The general procedure for the synthesis of benzimidazole derivative: 0.01 mole of 4-chloromethyl 7-hydroxy-2H-chromin-2-on is heated with 0.01 mole of 5-methyl 1H benzimidazole 2-ol in presence of 5 ml of 10% potassium hydroxide solution for 2 hours. Cool to room temperature. Precipitate out title compound with addition of dilute hydrochloric acid. Melting point of the synthesized compound was recorded with open capillary method. Now general procedure for the fourth derivative, that is mercaptobenzimidazole derivative. 0.01 mole of 4-chloromethyl 7-hydroxy-2H-chromin-2-on is heated with 0.01 mole of 1H benzimidazole 2-thiol 2-mercaptobenzimidazole in presence of 5 ml of 10% potassium hydroxide solution for 2 hours. Cool to room temperature. Then precipitate out title compound with addition of dilute hydrochloric acid. Then melting point of synthesized compound was recorded with open capillary method. Now we will see the applications. Coumarin have variety of applications. It is used in many aspects. First, anticoagulant, has blood thinning, anti-cancer, antioxidant, antiviral, anti-diabetic, anti-inflammatory, antibacterial, anti-fungicidal, anti-tumor activities, anti-neurodegenerative agents. Now next, treatment for the skin disease like psoriasis, eczema. It is used in the treatment of asthma and lymphedema. It is also used as a food additive and ingredient in perfume. Now result and discussion. We all got the results by using IR and NMR study. For the piperidine, we got the results by using FTIR, which is for NH stretching we got the value 3190.40. Then for OH stretching 3283.64. Then CS stretching for 2932.45. then for C double bond O stretching 1705.84 centimeter inverse. Then for CO C stretching 1146 for 74 centimeter inverse. Then NMR, for the NMR we got the 7.0.3 to 8.1 value. Next, 1H of OH value is 4.7. Then for CH3 we got the value between 3.5 to 4. Likewise, we as we can see in this slide and in this table, we got all this value for this coumarin derivative. Now conclusion. We use green chemistry approach to reduce the use of toxic and hazardous solvent and perform reaction using non-toxic chemicals, as well as by performing reaction under solvent-free condition. Our work is based on synthesis of coumarin scaffold under solvent-free condition using different green catalysts. Here we synthesize coumarin ring by Pachman condensation using green catalyst instead of using hazardous one. Reference. We got this reference from these various articles. Lastly, I would like to thank to Dr. Shivajirao S. Dondole, Dr. Geeta Khare ma'am and Dr. Nitin Mohire sir. If you like the video, please like, share and subscribe. Thank you.